Welcome back to another edition of Algebra 1. Today we're looking at Lesson 1-5, which has to do with expressions involving absolute values. So I'd like for you to begin by pausing this video, completing the warm-up on a piece of paper, and then unpausing to check your answers. So hopefully you paused and completed this. So we're going to look at which letter corresponds with negative 0.7. So I'm going to assume that would be letter D because letter D is the only one between 0 and negative 1, and that's where negative 0.7 would fall. 2.4 is F. Almost halfway, but not quite. The square root of 8. What is the square root of 8? Well, I know the square root of 9 is 3, and the square root of 4 is 2. So this should be really close to 3, is what I'm thinking. And if we look up here, G is very close to 3. Negative 2 is C, right here. And 2 1/4 is E. All right, moving right along. We're going to launch the lesson on expressions involving absolute values by reading this little article here. It says in 1883, Claude Monet painted his famous, I don't know how to say that, I'm not even going to try to butcher it, sunset. Specifically, he painted it on February 5th at approximately 4:53 p.m., according to Texas state researchers. Using topographical measurements, planetarium software, meteorological data, and Monet's letters, or maybe it's Monet. Is it Monet? I don't know. I'm a math teacher. I should probably have looked this up beforehand, huh? But Monet painted the cliffs and setting sun with a margin of error of 1 minute. The margin of error indicates that the actual time likely falls within 1 minute of 4:53. Therefore, the margin of error tells us that the earliest Monet painted the cliffs was 1 minute before or at the latest 1 minute after that 4:53 time period. So the way that we can express this is by using absolute values. Absolute values tells us how far a number is from 0 on the number line. So if I think about having my number line and I've got 0 right here in the middle, the number 1 is exactly 1 unit to the right of 0, and negative 1 is exactly 1 unit to the left of 0. So both the number negative 1 and positive 1 are the equal distance from 0 on the number line. That's what this is talking about. Here we're talking about a margin of error of 1 minute. So that means it could be 1 minute to the right of 4:53, or it could be 1 minute to the left of 4:53. And we're going to look at some more problems involving this as we progress through the lesson. So today's standards is using a structure of an expression and identify ways to rewrite it. So we're going to learn to evaluate expressions that involve absolute value. So for the vocabulary, in order to be able to answer questions about absolute value, we have to know what is the absolute value of a number. And it's important to understand that the absolute value of a number is simply the distance that number is from 0 on the number line. It could be a positive distance, it could be to the right, or it could be to the left of 0. It doesn't matter. Either way we go, it comes out as a positive distance. Because when we're talking about distance, I would never say, if you would like to travel to Weaver's West, then you go to the light here at the school entrance and travel west -2 miles and you will see it on the left. No, we would say we travel west 2 miles. Even if I go to the east to go to Boland's up here, I'm going to say, okay, instead of going to Weaver's West, maybe you want to go to the east and go to Boland's, to Boland's. So instead of taking a left at the light, you take a right at the light and travel 2 miles east to Boland's. So either direction I go, we say it in a positive, we use a positive number to identify that direction. And that's what we do with absolute values. Since it's talking about a distance it is from 0, we always have a positive number. So how can you find the distance between any two values, x and y, on the number line? Well, all you have to do is count the points in between them. So between 0 and 12, there are 12 units. In between 0 and negative 12, there would still be 12 units. So we can take the largest number and subtract the smallest number to find the distance. We could even take the smaller number and subtract the larger number, and you'll see we get a negative number. But when we talk about distance, once again, we don't say negative, we say a positive. So the distance between x and y is 12 units. Even if I say it's positive, even if I get the negative 12, we read the distance between x and y as a positive 12 units. So when we're evaluating expressions involving absolute value, one more time, well, probably not one more time, I'll probably say it 100 more times, but again, it's always going to be a positive number because we're talking about distance, and distance is positive. So for any real number x, if x is positive or 0, then the absolute value of x is x. If x is negative, then the absolute value of x is the opposite of x. So for any real number x, the absolute value of x equals x using symbols if x is greater than 0 or equal to 0. And if the absolute value of x equals negative x, this is only true for values of x that are less than 0. So if I have the absolute value of negative 7, then the absolute value of negative 7 is a negative 7, which gives me a positive 7. So absolute value of m, if m is negative 6, the absolute value is 6. Okay, the negative absolute value of n. Well, n is 4, so we have the absolute value is 4, and then we have that negative on the outside, so it attaches to it. The absolute value of negative p, well, p is 2, so negative 2. The absolute value of 2 is 2. And the absolute value of a negative 6 is a positive 6. We take the absolute value of that positive 6, we get 6. And then the negatives on the outside, so we still end up with negative 6. And those are our correct answers. So example 1 in your workbook, if you're following along in your workbook, is on the bottom of page 45. It says the absolute value can represent the amount by which two quantities or measurements differ in size. If x and y represent two quantities or measurements, then the absolute value of x minus y and the absolute value of x minus y represents that distance between them, and thus represents the difference in size as a positive number, because all of that is inside the absolute value. So it's going to come out as a positive. There's a something flying around me. So looking at the accuracy of a meat thermometer, it's the positive difference between the temperature reading on the thermometer T and the actual temperature of the meat M. So expand to see which expressions are and are not equivalent to the accuracy of a meat thermometer. So we've got the temperature of the meat minus the temperature of the actual reading on the thermometer. So we've got meat minus thermometer. This expression is equivalent because it represents the difference between the measurement and is always positive because it's the absolute value. This one is not equivalent because we could take this and get a positive value or a negative. No, we'd get a positive, and then let's say we get a positive, but then when we subtract them, that difference could be a negative value. So the expression is not equivalent in all cases because if T is greater than M, then my answer is going to be negative, and we know that it has to be a positive value. Okay, this one would be correct. The expression is equivalent to the accuracy of a meat thermometer because it represents the measurements, the difference in the measurements, and it's always going to be non-negative. And like M minus T, the absolute value of T minus the absolute value of M is not, because once again, this time if M is bigger than T, then we're going to end up with a negative value, and that's not going to work. All right, so just a little study tip. Remember, opposites. If A and B are real numbers and they're not equivalent, they're not the same value, then the difference of A minus B is going to be the opposite of B minus A. But the absolute value of opposites are always equal. So the absolute value of -1 is equal to the absolute value of +1. Okay, looking on to example 2 in the middle of page 46. To evaluate an expression that contains the absolute value of an algebraic expression, first substitute for all the variables. Next, apply order of operations to evaluate the resulting numerical expression. So we know that x is equivalent to 6 and y is equivalent to -3. So we're going to substitute the x with a 6 wherever I see an x in the equation. I'm going to replace it with 6 wherever I see a y. I said equation, I meant expression. I'm going to replace it with a -3. So -2 times a +6 times a -3 plus 5 times -3. Order of operations tells me to multiply this first. So a negative times a positive gives me -12 times a -3 makes it +36. +5 times -3 leaves me with a -15, read as 36 minus 15. Now we can subtract. So now we are left with the absolute value of 21. So what we're asking is how many units away from 0 is 21? It is exactly 21 units away from 0. So my absolute value of 21 is 21. Another study tip. Apply order of operations. Always perform all the multiplication from left to right and then do the addition and subtraction, whichever comes first from left to right. Example 3, we're just buzzing right along with this lesson. When evaluating algebraic expressions, absolute value bars act as a grouping symbol. So perform any operations inside the absolute bars first. So what's in there is, it's kind of like having parentheses. Those absolute values act as parentheses. It's a grouping symbol. But the difference is parentheses are just parentheses. But absolute values tells me it's looking for a location. It's asking me how far that number inside of there is from 0 on the number line. So we're going to replace all of my x's with 2. And you can see that's what they did here. They replaced my x with 2. Then they went ahead and multiplied that 4 by 2 and got 8. So next we've got to simplify what's in the absolute values because it's as if it's what's in parentheses. It's grouped together. So we add that 3 plus 8 together and get 11. So next what we're going to do is then go ahead and take the absolute value of 11, which I know is 11, and now we can evaluate what is 23 minus 11. That is 12. All right, example 4, or if you want to take a moment to go ahead and do the lesson check at the top of page 46. And at the bottom of page 46, and there is no example 4. So this is it for this lesson. We have looked at evaluating expressions involving absolute value, and that sums up today's lesson. I hope that it made sense to you.